I wanted to go through the process of deploying a Kubernetes environment using Kubespray. And while it may not be obvious as to why one would want a Kubernetes environment when you can just use the cloud to provide that, there are certainly cases where it makes sense to be able to actually manipulate the underlying Kubernetes resources and specifically the Kubernetes control plane resources. In this case, we had a customer that was looking to deploy with Kubespray and wanted the flexibility of deploying potentially into private cloud or public cloud as a backing resource for some of the tools that they were looking at. So we ran through this, and I thought this would be useful both for them as just general guidance in how to repeat these steps, but also for others in one way of using and deploying and installing with Kubespray. So Fred and I did some work on this recently and put together this model. There's a Git repo that we've got. You can do git clone https github.com Kumulus Tech, and it's kubespray/install. So I'm doing this in Google Cloud Shell. I'm actually going to use Google's Cloud Shell system and services to manage this environment. We're going to use some Google compute instances. And we're doing that even though most people would probably do this in something like Packet, where you have hardware. And that would be one reason that you might want to do this for hardware accelerated Kubernetes. But in this case, they wanted to be able to test in the Google environment, and that added an extra layer of overhead because you have the whole VPC segregation of your network. So anyway, so we have our Kubespray install, and I'm using the Cloud Shell editor here just because I think it's a nicer way of looking at files. There's a README that tries to document in excruciating detail how to go about this, and this installs not just the underlying Kubespray Kubernetes environment, but we also get EFK set up with an EFK target. We're using HA proxy to front a couple of worker nodes, and we set up DEX and open LDAP so that you actually have the ability to authenticate users into your Kubernetes environment. In order to get some machines running, I have put together a launch script. So this launch.shell script. This is not currently in the Kubespray install repo, but I'll probably drop it in there. It's just a bash script that goes through, pulls out a node for the HA proxy, and it's also going to be NFS, and so it actually sets that with a 200 gig disk, so there's a little bit of disk space available. It says that it's going to use that for HA proxy and NFS, and it builds an Ansible inventory as we sort of go along. It's going to spin up some master nodes. It's going to spin up a couple of worker nodes and just set up the rest of the inventory as required by Kubespray. So we'll have that file built for us from this. It also goes through, if you don't already have some firewall rules opened up to allow HTTP, HTTPS access, it'll set those. And I also set up one for the API, the Kubernetes API 6443. But it also checks to make sure that they're not already configured so that you don't have to keep doing it over and over and over again. So we should just be able to launch this. Launch.shell, and it'll go run through this. This will take about 5 minutes or so. So I'll speed this up when I post this recording. Okay, so we have a set of nodes. We have an inventory file here. If we look at the inventory, it's got both a set of public addresses, the 35 dot addresses, and internal addresses. This is important because from the perspective of most of the resources, we want to be talking to the public addresses. Those are the ones that are going to be responding and available to resources. But the internal addresses are still being consumed by Kubespray in certain instances. So we just wanted to make sure that we had that. We're going to now copy this inventory, since this is the right format for what we need, into the Kubespray install directory. So we have, we're just going to do copy inventory into Kubespray install. And we have a default directory and the host.ini. So this default is actually the Kubespray default inventory and variables repository. And we're going to be using that in the future for other services. So now that we've got our inventory defined, we could also have hand edited that based on whatever nodes we had created and built. We can go ahead and go into our Kubespray directory. Might as well grab our Kubespray code itself. I didn't actually include that in this bundle. We're going to clone HTTPS. GitHub.com, Kubespray. All right, let's grab the latest version of that. All right, so we've got that. There are versions of the examples and variables directories in there too, but we're going to use the ones that we've got because we've modified them already just a little bit to cover some of the use cases that we have. Now in the README, actually rather than doing more, we can just look at it here. In the README file, we point out that you do need some prerequisites. We need to have Ansible. Obviously, we need Git. I've already been using that, going through some of those steps already. But let's go ahead and create this virtual environment because we do need Ansible and we do need the NetAdder code installed. So this will take, again, just a minute to get everything migrated, moved, and up and running, hopefully. I tend to put tools in virtual environments. In this particular case, since we're already running within a container, that's what this little cloud shell is. It's not really realistic to try to run a container inside of a container. There are ways of doing that, but not here. So in this case, a virtual environment is like a container for us for our Python code. It just keeps things a little bit simpler. And we also need the NetAdder code. That gets used for making sure that we're configuring the right IP addresses for some of the services that we're manipulating. Okay, with those two pieces installed, so here now we have Ansible, so the virtual environment is actually doing the right thing. We can do two things. Now, in order for Ansible to work, we need to be able to SSH and log into these different resources. The default Google nodes that have been deployed don't have Python installed, and Ansible is a Python tool, so we need to get Python installed. I'm also going to install another SSH key just to make sure that I have access not only across the machines, or rather to the machines which I already have, so I can SSH to any of the machines from the Google Cloud Shell. It's one of the reasons that I deployed from here. But the individual machines may need to talk to each other as well. So I just want to make sure that I have a key that's been confirmed and works across the machines. Not the best security practice, mind you, but it's workable for this sort of a situation. So we're going to do an Ansible Playbook. We're going to use the inventory from our default host.ini file, and we're going to use the ssh.yaml script that's here. This playbook. Yeah, I have a group and a host with the same name. I should have probably called it something else. So we're getting Python installed on the machines, and then we're going to upload a key. Not quite sure what happened there. Let's just rerun this real quick. I do know what happened there. We kind of probably want these keys here. Actually, what we really should do is make a new set. All right, so let's try this one more time. Okay, great. So now that we have the SSH key synchronized. I have Python on there, which was really the heavy lifting thing. The next thing I want to do is I just want to get the HA proxy environment up and running. So I'm going to go into the HA proxy directory that we have here. We've got a couple little plays. The inventory here is just an example inventory. We're not going to use that, but we are going to say Ansible Playbook -I, and we're in the default hosts.ini file, and we want to run the haproxy.yaml parameter here. So this will go ahead and update the HA proxy node to have HA proxy installed, and that's important for us for enabling the load balancing against the 3 master nodes that we're going to deploy. It shouldn't take all that long. It's installing from package, so it installs a config file, and the config has the public address in it, and so that's the core of what we needed. The other tool that we want to install on that same node, we're also going to make this an Nfs server so that we can do persistent volume claims and persistent volumes within the Kubernetes environment. So we have an NFS directory here. So we're going to do the same thing. There's an NFS project. There's some other YAML to actually test and validate the system later, but we need a Kubernetes environment to do that. So we're going to go ahead and do, again, Ansible Playbook -I inventory, not inventory, I want to use, / default host.ini, and helps if I pass the nfs.yml playbook. And so this just makes sure that NFS is installed. It does expose or export the public directory, and we'll need that later as we go through the actual README documentation here. So far we basically have just done these steps towards the top, making sure that we have the right resources installed. Because we're in the Cloud Shell, there's talk here about installing kubectl and Helm, but they're both already installed, so we don't need to do that. The inventory was auto-generated, but there is an example. There is a host.ini in the default directory, so there's an example that you can leverage to sort of fill out with your specific nodes. And then we can get into Kubespray. So there are some things that we want to modify in Kubespray before we actually create the cluster. You could actually just do a Kubespray deploy right now, and it would get close, but there are some IP addresses and things like that we want to add in specifically for the HA proxy API service. I've already done this git clone, so we have our Kubespray environment. And specifically, we need to modify the supplemental addresses in the group variables all, and we need to make that match the IP address for our load balancer. So what we're going to do is we're going to go up a directory. So we're still in the Kubespray install directory. We're going to look at the default host.ini file because we need 2 parameters, specifically the proxy. We want to grab these 2. I'm just going to grab this entire string. Got to get rid of this internal IP bit, but we can then go to, let's see, it'll be in default, group vars, all.yaml, and I've set it up here at the top. So we need the external and the internal IP address, comma separated, so we can just paste that in here, get rid of this particular part of this. All right, if we wanted to give it an address, if you wanted to update a DNS entry, for example, you could add that here as well. So we have the public address and the private address for the load balancer. So that should allow the SSL certificate for the API to have the appropriate addresses in it. So that's good enough for now. If you had multiple load balancers, so if you really did have a load balancer sort of an environment, or an HA proxy and keep alive D multi-HA load balancer setup, you'd probably update this with all those addresses so that the keys that get created are complete for the TLS certificates. And the rest of this should be fine. So we can go ahead and save this, which is, I think it's Command S. Yeah, Command S. All right, so we've saved that file. That's the first part of it. So let's go back to our README. Okay, so we've updated that. We've prepared the basics of Kubespray. We've made sure that our HA setup was available. We'll get back to Helm in just a second. That's a little bit out of order. I want to make sure that we have our ingress controller set up correctly as well. So here there are two things. There's the clusters add-on.yaml. We want to make sure that we have our ingress enabled. I think I've already done that in here for us. So under cluster add-ons, let's see, Helm is false, dashboard's true. Okay, yeah, so I've already set the ingress parameters that were defined here in the README. If we go back to the README, I need to edit this, that way it'll keep my space, keep my place. All right, so yeah, we defined the ingress, but the other thing that we're going to do, since we don't have, or we're not going to use the Kubernetes load balancer service, or the load balancer model is a part of Google Cloud, and we're doing this manually. We want to set up node port for ingress, and in order to do that, we've modified the default backend role as follows. So we're going to go ahead and grab this code. So copy this. And then we're going to go find in the Kubespray directory role app ingress controller templates. So we can go here into Kubespray roles, Kubespray apps, and not Kubernetes apps. It is Kubernetes apps. Ingress controller, ingress nginx, templates, and here is the service default backend YAML. Great, so we're going to just replace this. There were a couple of changes, specifically the selector has changed, and the port and target port changed in order to make this work properly, at least in our environment. All right, so that should be it for ingress. We'll do Dex after we have the cluster up and running. Or was it? Yeah, I think we need to do that after the cluster's up and running. So now we can go ahead and launch the cluster, and we do that somewhere here. Actually, I guess we do want to do this before we get there. So let's go into the cluster and uncomment the kube OIDC auth. Make all this small. So we want to make this true. Yeah, it probably is trouble. All right, so we made that true. It looks like there's some modification that's going to need to be done to support this after the service comes up. So we're going to deploy Dex to manage our OpenID provider. And in this case, we're also going to have to then configure all this. We'll come back and do this as part of a follow-up. But right now, I'm going to go ahead and grab this. And here in the Kubespray directory, we should be able to just paste it. All right, so this takes 10-15 minutes, and once it's done, we should have a running Kubernetes cluster, and we can do more things like set up NFS, etc. Again, I'll speed through this part once we actually get the cluster up. All right, so at this point we actually have a running cluster. It certainly does take a little while to go and build it. The one piece that we still need to do before we can actually run kube control, so normally you'd run kube control. and it would be able to talk to something. We have to tell it where the kube control configuration is, and in this particular case, Kubespray creates a default admin config and it dumps it for you. It puts it in the default artifacts directory, so we can export kube config equals $pwd default artifacts admin.conf. But that's not quite enough because this is still using the internal address for the resource rather than the external address. So if we do it more on default host.ini, we can capture the HA proxy address here, the external address, copy that. And then we can edit the default artifact admin.conf. We can look for 10 dot something or other, and here it is. So we can grab this address, delete it, insert the new address, and so now if we do kube control versions, good one. Helps you do it right. How about version, not versions? We see that we can get both the kube control client version and the server version. That's perfect. That means we're actually able to talk. If you do kube control get pods minus kube system, for example, here we see we have our resources running. I know that one of the things that seems to have some issues is the dashboard doesn't seem to want to create by default. Not quite sure what's going on with that, but that's not really the key resource here anyway. But that's a basic Kubernetes environment running. The other thing that we want to do is get Helm installed, because things like the NFS backend, Open LDAP needs DEX, that all wants Helm. And so I think our Helm instructions were up here. So first we need to get Helm, but then we need to create a service account for Tiller, which is the client, the server side of Helm. We also need to create a cluster role binding so that Helm can actually run. So we can actually do these two things real quick. Oops, looks like I have a... All right, so I've got that, and then we should be able to do a Helm init with our Tiller service account, and that'll do its thing. We did not do the TLS configuration for this. Something we can do in another deployment. And with that, let's see, kube control get pods, kube system. Okay, well, it'll take Tiller a little bit to deploy. At that point, we should have a running system. If for some reason that doesn't work, the easiest way to fix it is to actually rerun the Kubespray Ansible Playbook -I default hosts, and then Kubespray cluster, and let that go through and complete. And that should adjust and address any potential inconsistencies that maybe didn't get configured properly in the fairly long run for this environment. We'll go through the rest of these steps in another recording, but I think this one's going to already be plenty long enough for most people to get through and at least get the basic system up and running. But we'll go through the process of getting the LDAP authentication working and finish out the NFS configuration, which is basically launching an NFS Helm chart and making sure that our persistent volumes are actually connected on the back end to the Nfs server.